Here we are in Chapter 4. In Chapter 4, we will focus on quantitative data. There are 3 videos for Chapter 4. In this first video, we will focus on displaying quantitative data. So quantitative data is data that deals with measurements. So this is data it's numerical, and the data typically has units. Categorical data that we talked about in the last chapter is data that describes categories like color, gender, model of a car, pass, fail, things like that. When you display categorical data, you typically use a bar chart or a pie chart. When we display quantitative data, we will use histograms, dot plots, and stem and leaf plots, all of which we will learn how to do today. The first graph we're going to talk about today is the histogram. A histogram looks a lot like a bar chart, and we'll be using histograms quite frequently in AP Statistics. A histogram uses adjacent bars to show the distribution of a quantitative variable. Each bar represents the frequency or relative frequency of values falling in each bin. So when you make a histogram, you group the data into bins of equal width, and the height of each bar is determined by the bin count. In a histogram, the bars can touch because the data is continuous. A relative frequency histogram is just like a regular histogram, except that the height of the bar is based on the percentage of cases in each bin instead of the count. So let's make a histogram using the shoe sizes of the students in my last year's stats class. First, I need to divide the data into bins of equal width. So how about 5, 6, 7, 8, etc. Then I'll mark the bins on my graph and start plotting the data. There are 2 in the size 5 category, so my height at size 5 will be 2. There are none in the size 6 bin, but there are 3 in the size 7 bin, 7 and 7.5. So my height at 7 will be 3, etc. So here's the histogram with a bin width of 1 full size. Let's do that again, grouping sizes. How about 5 and 6 together, 7 and 8 together, 9 and 10 together, etc. So here are 2 histograms that show the same data. The first one has a bin width of 1. The second histogram has a bin width of 2. So we have size 5, 5.5 here, size 6, 6.5 here, 7, 7.5 here. Here we put 5 and 6 together. So this is 5, 5.5, 6, 6.5. The next size is 7. So the bars do touch. This is somewhat continuous data. So you can see from this that histograms will look different if you choose a different bin width, and that's okay. To recap histograms are extremely useful when you're working with large sets of data, and they're easy to construct with your graphing calculator. A disadvantage of histograms is that they usually do not show the individual data values. That's because you're grouping things into bins. So all the 5s, 5.5, 6, 6.5, all those shoe sizes went in the same bin. You don't know what was what in that bin. Alright, as a general rule of thumb, your histogram should contain 8 to 10 bars. Now, if you have a small data set, you might have fewer bars. If you have a large data set, you might actually have a lot more bars. So it's just depending on what you want to show and what your data looks like, how many bars you're going to have. Okay, let's look at stem and leaf displays. So the histogram on the left shows the pulse rates of 24 women at a health clinic. The stem and leaf display on the right shows the same data, just in a different form. So a stem and leaf plot, as you can see, is similar to a histogram, except that it shows the individual values rather than bars. So you can see that some woman had a pulse rate of 56 beats per minute, and that probably corresponds to this value here, although you cannot tell for sure that is 56. It may be 55, it may be 56, maybe even something else. Next, we're going to make a stem and leaf plot. First, we're going to kind of cut the data into stems and leaves. And we'll use the stems to label the bins, and you're only allowed to use 1 digit for each leaf. So let's give that a try. Here's data for the number of states visited by my AP Stats students last year. You can see that one student visited 4 states, one visited 7, 3 students had visited 8 states, a couple had visited 9, etc. Now we're going to divide each data value into a stem and a leaf. We're actually going to cut the digits apart. So let's just draw a line right down the center of our data values. And on the left will be our stems, and on the right will be our leaves. So in front of all the data on this side, if there's nothing there, that's going to be a 0. So this would be 04, this would be 07, 08, etc. Okay, over here I have the stems listed. I'm actually going to split the stem so there's not too many data values in each stem. So the first 0 corresponds to 0, 1, 2, 3, and 4. This will be 5, 6, 7, 8, 9. This will be 10, 11, 12, 13, 14, 15, 16, 17, 18, 18, 19, etc. My first data value is 4, so over here 4 is going to be with the first 0, so I'm going to write 04. 7 is going to be with the second 0, so I'm going to put the 7 here, as well as the 8s and the 9. There are 3 8s and 1 9. Now here we have 10. Well, 10, 11, 12, 13, and 14 all go here, so I'm going to write 10, 10, 11, 11, 13, etc. This is the finished stem and leaf plot. This first number corresponds with 4 from our data. This number corresponds with 17 from our data. This is the tens place, and this is the ones place. This number corresponds with 23, the last value in our data. A stem and leaf plot looks a lot like a histogram. It looks a lot like a dot plot. One thing about a stem and leaf plot is that it preserves the original values. You should also include a key with a stem and leaf plot, so that's what I've just added right here. A back-to-back stem and leaf plot is useful when you want to compare two distributions. Maybe you want to compare the number of states visited by male students to the number of states visited by female students. I'll put the males on the left and the females on the right. 2 of the guys have visited 8 states each, and 1 of the guys had visited 11 states each. This is still the tens place of the stem, and this is still the ones place. If someone had visited 38 states, I'd have the 3 right here and put the 8 on the left if that someone was a man. This is the completed stem and leaf plot. You can compare the females to the males. Stem and leaf plots are used for quantitative variables just like histograms, and one advantage is that they actually preserve the individual data values. Stem and leaf plots are best for small to medium distributions. Use a histogram for a large set of data. So how would you set up the following stem and leaf plots? I want you to take a minute and make a sketch. Remember that you can only use 1 digit for the leaves, but you can use 1 or more digits for the stems. Here's my idea for the stem and leaf plot for quiz scores. So here is the tens place, and this is the 1. So if you got a 55, that's right here. If you got a 63, that's right here. A 68, a 69, a 69. And I've included a key. Here's one way to do stem and leaf plots for student weights here in purple and possible SAT scores here in blue. First of all, I figured out the range for weights could be between 90 to 290 pounds. So here is 92, here is 106 and 108 pounds, etc. up to 29. For SAT scores, scores are reported with a 0 at the end. So 350 would look like 3 stem 5. This would be 590 right here. 600, 605, 650, and 670, and here is the key. Dot plots are the simplest charts to make. You start with a line graph like this, and then you just place dots at the appropriate place along that graph. Dot plots are often drawn like this one here. If you make a dot plot, make sure your dots are nicely spaced like these, not kind of unevenly spaced like something like this. There should be an equal space between each dot. Dot plots are best for working with small sets of data. Think before you draw. Remember that dot plots, stem plots, and histograms are really only good for quantitative data. If you want to graph categorical data, you should use a bar chart or a pie chart. That's all for the first video for Chapter 4, displaying quantitative data. Our next video will be summarizing quantitative data.